Welcome back to Chapter 3 lecture, and we're going to talk about rotating limbs and projected objects. Another set of principles that we need to take into account when discussing motor skills is rotating limbs and projected objects. For example, when we're throwing a ball, what do we need to take into account when trying to throw the ball really fast? There are a couple of factors that we do need to keep in mind, and one of them is the kinetic chain. The principle of the kinetic chain is that the motions of one segment of the body have an effect on the other parts of the body. Continuing with the example of the throwing ball, when the shoulder joint moves, it affects the motion of the elbow and the wrist. A skilled movement takes into account the relationship between the joints and uses the relationship to exploit principles. After taking into account the kinetic chain, we can use the equation of the angle of rotation in order to make the ball go really fast. In kicking or throwing, velocity is dependent on two factors: the length of the arm or leg at the point of the throw, known as the radius of rotation, and the speed of the rotation, known as the angular velocity. Based on this principle, an extended arm elicits a greater linear velocity, but an extended arm throughout the motion results in a greater inertia, making it difficult to accelerate. We can see here in this example of a skilled pitcher throwing a ball. He takes advantage of both the radius of rotation as well as the angular velocity. And he counteracts the inertia of having a straight arm by cocking or winding up and bending his elbow before extending and releasing the ball all the way through. So he's exploiting the movement by keeping his elbow bent until the time of maximum acceleration in order to reduce the inertia, and then he extends his arm finally to increase the radius of rotation. So far we've talked about ways to generate the most force, but we haven't yet discussed force absorption, which is also a key principle in executing motor skills. We can change the amount of force experienced by changing the time of contact and by extending it. By extending the time of contact, we're able to reduce the amount of force experienced, and this can be done by bending the knees or moving in the direction of motion. So if you're jumping, for example, by bending the knees, you reduce the amount of force exerted on the knee joint. And moving in the direction of motion is typically seen by a follow-through, rather than stopping abruptly. Another way to reduce the amount of force experienced is by increasing the area of contact in order to reduce the amount of pressure that we feel. For example, this would be marching in high heels versus marching in flats. So if we have a heel, you have a reduced area of contact onto which the force is exerted, but in flats you have the entire foot onto which all of the pressure is experienced. Additionally, we also need to talk about stability and balance and their relationship in shaping motor skills. Stability is defined as the ability to resist movement, and balance is the ability to maintain equilibrium or hold a position. Based on these definitions, we can be balanced as we are maintaining our equilibrium, but be unstable because we are unable to resist movement. We can increase stability by increasing the base of support, lowering the center of gravity, and keeping the center of gravity within the base of support. So for example, if we are standing on one leg, we're balanced, meaning that we are not falling over, we're maintaining equilibrium, but we would definitely not be stable, as if someone came to push you over, you would fall down. And a way that you would increase your stability here is by increasing the base of support by putting your other foot down, making the base wider. You could lower the center of gravity in this case by lowering your knees, bending your knees, and by keeping the center of gravity within the base of support, meaning keeping your body upright rather than leaning in one direction or the other. While maintaining stability is important for some movements, we are better exploiting the principles by remaining unstable. For example, running, walking, and locomotion in general are examples of us falling and catching ourselves over and over again. When you walk, for example, you propel yourself forward and you catch yourself because your base of support falls outside of, your center of gravity falls outside of your base of support, and by putting your other foot forward, you end up catching yourself. The transition from stability to mobility is probably one of the most challenging aspects of development, as there are many factors that influence this transition, and they constantly change throughout the process of development. So finally, to wrap up this lecture, how do we need to correct and detect errors in motor skills from a coaching or physical therapy perspective? We first of all have to observe the skill, and when doing so, you have to be thorough and videotape if needed. You have to analyze each phase of the skill and its key elements, the preparatory phase, the action phase, and the follow-through, and use the knowledge of the principles of mechanics in order to better understand what forces are taking place during the motion. You have to select the errors to be corrected and prioritize major errors that affect the larger aspects of the motor skill. When correcting for an error, you have to decide on a specific method of correction, and the correction should be activity specific. So this lecture will help you do the assignment that we have for this course, and you have to identify the principles of motion from the photos. Your task is to identify the goal, how the forces are generated, are the forces generated, forces linear or rotational, what are the commonalities across the image, and how you would train the individual to help them move better. If you have any questions at all regarding any of the principles of stability and motion, or any questions regarding the assignment, please feel free to email me and I'll get back to you ASAP. I'll see you guys in the next lecture.